Welcome folks. In this session, I'm your host Amit, and in this session, we are going to discuss the palindrome linked list problem. So without any delay, let's look at the problem. So as we see here, the problem states that given a linked list, we want to figure out if this list is a palindrome or not. If this is a palindrome, we need to return true, and if this is not a palindrome, we need to return false. Okay, so what's the first thing that comes to your mind? The first thing that comes to my mind is go and reverse this linked list, and then by one compare both those linked lists. If they are same, if they are exactly the same, then this is a palindrome linked list. But can there be a better approach? Here what we are trying to do is the space complexity is order of n. Can we reduce this space complexity to order of 1 without increasing the time complexity? The time complexity here should not be more than order of n. Okay, so we know like one of the approach which we already know, reverse the linked list and check it. What can be the other approach? Okay, so let's discuss that other approach. So this approach says that we can have a slow pointer and a fast pointer. So if you have not already watched about the slow pointer and fast pointer, please go back to my previous video and watch about the slow and the fast pointer. If you have not already seen the reverse linked list video, then you can please go back and watch that, because both the approach can be used here in finding if a linked list is a palindrome or not. So let's see this approach. So we have a slow pointer and a fast pointer. So what we do here with slow pointer, that slow pointer goes 1 by 1 and the fast pointer would go by 2, right? Fast pointer would go by 2 and slow pointer would go by 1. So there can be a few cases here. If this length of this linked list is even, then we would reach, if we are when our fast pointer reaches the end of the list, our slow pointer would reach in the middle of the list, right? But if it is even, right, in that case, our slow pointer would reach the element just before the middle one. Okay, so let's see that one. Okay, so this also has odd number of elements, so this has even number of elements. So when 1 2 3 we reach there, 1 2, okay, because we will check like in the end if our next or next to next is null in the fast pointer. So at that point we would move only 2 steps and we are just behind the last element. Okay, so with this intuition, let's try to solve this problem. Okay, so what we would do here is like once we reach the end of the element, so once we reach the middle of the element, then what we would try to do here is we would try to point that particular element, the middle one, would point to null, and the elements which are next to it would start pointing to this one. So we would reverse the elements which are at the after the middle of this element. Okay, and then we can start our pointers from both the ends and see if they are converging to the same pointer, and if they are converging to the same pointer, then we already know that we are at, so this is a palindrome, otherwise it is not a palindrome. Okay, so let us try to implement it. So we would have 2 pointers, a slow pointer and a fast pointer. Okay, then we would try to start a while loop, and we would iterate till our fast reaches the end of the list. If this is the case, and fast would be okay. So now fast has reached the end of it. Now let's have one more list node. Start that with null. Let's call it previous, or maybe we can call it current. and we would have one more element which we can call temporary, which we would be using later. Okay, so what we can do is we can start our current with slow, because we have reached up to that element, and we want to, okay, so we want to point this element to null. Okay, and the next element we want to point to this element. So we would start with slow dot next, and current dot next we would point to null. Okay, so now half of the list is there, then half of the list is starting from slow, and the slow we would keep iterating till the end and reverse this, means which we reach the end of the list. Till that time we would use that temporary here, and that would be slow next. Okay, and because we have that reference and this slow dot next, we would point to current, and now the current, we would move the current forward, and then we would the temporary value that we stored, like the next element which we of the list that we want to reverse, we would point that to slow, right? So now our list is, so from the middle the list is kind of reversed, and from both ways we are converging to the same element, which which is pointing to null. And okay, so now we want to start from both the ends. Okay, and we want to start from both the ends, and at one end we have current, which is actually pointing to the last element, and means at one end of the list current is pointing the one end of the list, and then we have head at the another end of the list. Okay, so we would make use of these two pointers. So we would have list node, pointer 1. Okay, and we would initialize with the head, because we have head at one end, and we have pointer 2, which is like the other end, and other end is being held by current. Okay, current is holding at the other end of the list, which is now being now already reversed. Okay, so while pointer 1 means one of those head of the list is not equal to null. Okay, because we are starting from this direction, and if we don't reach this end of the null, we would keep checking from the other end. If pointer 2, which is other end of the list, dot value, so if this value is not equal to pointer 1 dot value, because they should all be same, in that case we would return false. Okay, otherwise what we would do is we would just keep iterating from both the ends. Okay, and we would keep iterating. We would keep pointer 1 equal to pointer 1 dot next, and pointer 2 equal to pointer 2 dot next. Okay, and at the end of it, if everything is fine, we would return true. Okay, let's try to run it. Okay, we get a problem here, cannot read from well because local 7 is null. This is at line number 33. Okay, so I think we should check from both ends, and if any of them reaches null, we should be terminating it, right? Right. Okay, yeah, makes sense. Oh, it should be an end condition. Okay, we are able to get a result here, and let's try to submit it and see. Okay, so we are able to run in 5 milliseconds, which is faster than 92.24%. Thank you folks, see you in the next one.